right, so we're starting chapter 7. Remember we just finished chapter 6 where we did all of our different, oops, there goes my camera, all of our different factoring. So now we're going to put that to use by working with some rational functions and rational expressions. So you can see, first of all, that a rational function is a function that can be written as a fraction, p over q, where the denominator can't equal 0, so you know that that's always been true. Some examples of rational functions or rational expressions would be something like 2x over 3y. That would be a rational expression. 8x plus 5 over 2x minus 3. Negative 5a squared plus 2 over a minus 1. So all of these are rational expressions because they're fractions and they contain an algebraic expression in the numerator and in the denominator. So first thing we're going to talk about is the domain of each of these rational functions. So now remember, domain just means the set of all of the x's that can be true. So if we look at a fraction, we always have to consider the fact that our denominator can't equal 0. So in other words, when we look at 1a, there's one value that I could plug in here that would make this denominator equal to 0. And that one value is positive 6. Now, I can get that by taking my denominator and setting it equal to 0. And when I solve that little equation, I would add 6 to both sides. And I get x equals 6. So 6 is the value that would make this denominator equal to 0. So what does that mean for the domain? Remember, the domain is the set of all of the x's that can be plugged in to my expression. So the domain would be every number except for positive 6, because 6 is the one number that could be plugged into there to get me a 0. So how would I write basically all real numbers except for 6? Well, you would write it as everything from negative infinity to 6. Now remember, these parentheses means that I'm not including the 6, union with parentheses 6 to infinity. So this would be the domain of that function. Basically, it says that the domain can be anything from negative infinity to positive infinity except for positive 6. Well, let's look at b. So again, how do I find my domain? Well, I'm going to take my denominator and I'm going to set it equal to 0. And this takes us back to where we were in chapter 6. How do you solve this equation? Well, you're going to factor. So we'd have an x and an x, and you want two numbers that multiply together to get negative 10 and add together to get negative 3. So this would be a negative 5 and a positive 2. So if I take each of these factors and set them equal to 0, I would get positive 5 if I take this and set it equal to 0. And I would also get a negative 2 if I were to take that second factor and set it equal to 0. So what that means is that these two values, when plugged into the denominator, would get me a 0. So my domain would be all real numbers except for 5 and negative 2. Now, if we just quickly look at a number line, let's look at what that means. So here's 5 and here's negative 2. So we want all of the numbers except for those two numbers. So let's talk about what that would look like in interval notation. So it would be everything down here. So it would be everything from negative infinity to negative 2, but we don't want to include negative 2. Union with, and then we need this part in the middle. So that would be negative 2 to 5. Again, skipping the negative 2. Union with, now we have to skip over the 5, and it would be 5 to infinity. So we actually have 3 intervals in our interval notation for that problem. And you can see those three intervals by looking at or kind of picturing the number line. Okay, so if we look at this last one, well, what would this be if I again, just the denominator. The numerator can be 0. It doesn't matter. It's just the denominator. So what happens if I take this and set it equal to 0? Or another way to think about it is what can be plugged into this denominator to make it a 0? Well, there's nothing that can be plugged in because there is no variable. So the domain for this one is simply all real numbers because all x's are going to work. Okay, so now that we know about domain, let's go and let's talk about simplifying each of these rational expressions. So in other words, what that means is we're basically reducing the fractions. So I have two key words that you have to remember here. You're going to factor everything that can be factored, and then you're going to cancel out any common factors. So we're going to factor both the numerator and the denominator if possible. So if we look at the numerator of this first fraction, first of all, that does not factor, so we're just going to rewrite that. How about the denominator? Well, remember, what's the first thing you should always look for when you're factoring? You should always look for a greatest common factor. And you can see that there's a greatest common factor here of 3y cubed. And when I take that out, remember, I'm undistributing, divide it back, I'm going to end up with 2y minus 1. Now I cancel any factors that are the same. Well, they both have a factor of 3. I'm going to cancel that. They both have a factor of y cubed, and those totally cancel out. So when all is said and canceled, I have a simple 1 left on the top. You always have to have something. And a 2y minus 1 left on the bottom. You can't cancel part of a factor. So for example, here you can't cancel out these 1s because this 1 is part of this whole factor. This is this expression in simplified form. So let's go over here and let's do this one. So again, now if we factor both the numerator and the denominator, if I look at the numerator, there's no greatest common factor, so I'm simply going to, because it's a trinomial, put down my two sets of parentheses, and I'm going to use guess and check. So let's see, 5x to the 4th, that can split up into 5x squared and 1x squared. Well, my 1 can simply factor into 1 times 1. Do you remember your rules for your signs? The rule is if the last sign is positive, it means both of the signs are the same. They're whatever the first sign is. So both of those would be negative. So I know this factors further, but I'm going to go ahead and I'm going to do that in the next step. So the next thing I'm going to do here is I'm going to factor the denominator. I've already factored the numerator at one time, and now I'm going to factor my denominator. So again, there's no GCF. I'm going to backwards FOIL. I'm going to guess and check. So how do I split up the 3x squared? Well, that's 3x and x. Now, how can I split up a 7 so that when I refoil, I'm going to end up with a 4? Well, let's see. 7 can only be 1 and 7 or 7 and 1. So there's my guess. Now, if I look on the outside, I have a 3x, and on the inside, I have a 7x. Can I get a positive 4 out of a 3 and a 7? Absolutely. The 7 has to be positive, and the 1 has to be negative. Quick check. That's going to give me 3x squared. Outside's going to give me negative 3x plus 7x. That gives me my 4x that I need, and then a negative 7. Okay, so now, as I said earlier, this factors further as a difference of squares. So I have to go down one more step. The first one doesn't factor any further. It's prime. Remember difference of squares? That's going to factor into x plus 1 times x minus 1. Neither factor in the denominator factors any further, so we're just going to rewrite. So now I'm going to go ahead and I'm going to cancel any common factors. Well, you can see the x minus 1s are common. So if I were to now simplify, because there's nothing else, it would be 5x squared minus 1 times x plus 1 all over 3x plus 7. And I wouldn't make you multiply those out of FOIL out the numerator. Okay, so let's look at C and D. These are interesting. So if we look at C, first of all, remember that addition is commutative. In other words, it doesn't matter what order you add two things in. So in other words, this top can be written as x plus 5, and the bottom is also x plus 5. So don't these simply cancel? What is anything divided by itself? It is 1. Now I know you're thinking that's pretty easy. Well, I want to compare that now with D. Is subtraction commutative? No, subtraction is not commutative. It does matter what order you subtract things in. So these two factors are not the same. You cannot cancel them out yet. What you want to do is you want to take either the top or the bottom, it doesn't matter which one, and we want to factor out a -1. Let's go ahead and factor out a -1 from the top. If I factor out a -1, that's going to make that a -5, and that's going to make that guy a positive x. Do you see that these are now the same? This is now an addition problem, so I could rewrite it by flipping these around, and it would look like x minus 5. I can now go ahead and cancel those common factors. And the answer to that one is -1. So you have to be careful. Look carefully if you can do that factoring.